The Genius of Relativity. Unraveling Einstein's Theory. Welcome to our journey into the mind of one of history's greatest scientists, Albert Einstein. Today, we'll explore his groundbreaking theory of relativity, a concept that revolutionized our understanding of time, space, and gravity. In the early 1900s, the scientific community was steeped in classical mechanics, rooted in the works of Isaac Newton. Newton's laws, established in the 17th century, described motion and gravity with remarkable precision, providing a framework that stood unchallenged for centuries. But beneath this solid foundation, there were cracks, hints of deeper truths waiting to be uncovered. Albert Einstein was born on March 14, 1879, in Ulm, Germany. From a young age, his inquisitive mind led him to question the nature of reality. Despite facing challenges in school due to his unconventional thinking, his fascination with science only grew. By 1902, Einstein was working at the Swiss Patent Office in Bern. While processing patent applications, he continued to explore physics on his own, conducting thought experiments that would later inform his groundbreaking theories. At the time, classical mechanics dominated scientific thought. Newton's laws provided a clear understanding of motion and forces. However, they assumed that time and space were absolute, unchanging, and universal. This assumption would soon be challenged. In 1905, Einstein published 4 revolutionary papers, each tackling different aspects of physics. Among them was his paper on special relativity. This was the moment when the foundations of modern physics began to shift dramatically. In his special theory of relativity, Einstein proposed 2 key postulates. First, the laws of physics are the same for all observers, regardless of their relative motion. Second, the speed of light in a vacuum is constant for all observers, regardless of their motion relative to the source of light. This meant that time and space were not fixed. They were intertwined in a single fabric known as spacetime. As Einstein famously stated, time and space are modes by which we think, and not conditions in which we live. To illustrate this, imagine a train moving at a significant fraction of the speed of light. For passengers inside the train, time ticks away as it normally would. But for someone observing the train from the platform, time appears to slow down for those on the train. This phenomenon, known as time dilation, challenges our everyday understanding of time. Einstein often used thought experiments to illustrate his theories. One famous scenario involves 2 twins. One travels in a spaceship at near light speed, while the other remains on Earth. Upon the traveling twins' return, they find that they are younger than their Earthbound sibling due to the effects of time dilation. This thought experiment vividly demonstrates the non-absolute nature of time. Special relativity had profound implications. It showed that energy and mass are interchangeable, famously summarized in the equation E=mc². This equation implies that a small amount of mass can be converted into a vast amount of energy, laying the groundwork for developments in nuclear physics. This understanding of mass-energy equivalence has had far-reaching consequences, from nuclear energy to the understanding of stellar processes in the universe. It also sparked debates about the philosophical implications of relativity, challenging notions of absolute reality. A decade later, in 1915, Einstein presented his general theory of relativity, which extended the principles of special relativity to include acceleration and gravity. This was a monumental leap, fundamentally altering our understanding of gravity itself. In this theory, gravity is not simply a force acting at a distance, as Newton had proposed. Instead, Einstein described it as the curvature of space-time caused by mass. Massive objects, like the Earth or the Sun, warp the fabric of space-time around them, creating what we perceive as gravitational attraction. This concept allowed for the prediction of several phenomena, including the bending of light around massive objects. During a solar eclipse in 1919, astronomers observed light from distant stars bending as it passed near the Sun, providing the first experimental confirmation of Einstein's theory. The world was captivated. Overnight, Einstein became a global icon, representing the triumph of human intellect and creativity. His ideas sparked a scientific revolution, influencing not only physicists, but also philosophers and artists. Einstein's general relativity has profound implications in modern physics. It serves as the foundation for our understanding of black holes, the expansion of the universe, and gravitational waves, ripples in space-time first predicted by Einstein in 1916. In 2015, scientists at LIGO confirmed the existence of gravitational waves, a momentous achievement that validated Einstein's predictions a century later. This discovery opened up a new way of observing the universe, allowing us to study cosmic events that were previously invisible. Yet, even with the triumphs of relativity, challenges remain. The quest to reconcile general relativity with quantum mechanics has become a central focus of theoretical physics. The two frameworks, while extraordinarily successful in their domains, seem incompatible in extreme environments, such as inside black holes. Physicists are exploring theories of quantum gravity, seeking a unified understanding of the fundamental forces of nature. Concepts like string theory and loop quantum gravity represent attempts to bridge this gap, but a complete theory remains elusive. Einstein's impact extends beyond physics. His ideas have inspired countless thinkers in various fields, from philosophy to art. He challenged us to reconsider the nature of reality and our place within it. Einstein was also a committed humanitarian, advocating for peace and civil rights. He used his platform to speak out against war and injustice, embodying the notion that scientists have a responsibility to society. In his later years, Einstein continued to explore fundamental questions, remaining curious and engaged with the scientific community. His humility, combined with an extraordinary intellect, has made him an enduring figure in the collective consciousness. As we reflect on the legacy of Albert Einstein, we recognize that his theories have not only transformed physics, but have also reshaped our understanding of the universe itself. His work invites us to embrace the complexities and mysteries that lie beyond our everyday experiences. Thank you for joining me on this exploration of Einstein's relativity. His legacy reminds us that, in the pursuit of knowledge, the universe is more mysterious and beautiful than we could ever imagine. As we look up at the stars, we are reminded of the profound questions that continue to drive scientific inquiry and inspire future generations.